Assalamu alaikum, hello, and good day to all. Today we will be discussing a coordinate geometry, the gradient and equation of a straight line. Also, the types of the gradients that we may have for a straight line. So, gradient is given by the formula which is y2 minus y1 divided by x2 minus x1, which is, so basically we can say that gradient is the ratio for step up to step down, or we can say it's the ratio for rises to run, or we can say it's the change in y divided by the change in the x values. Meaning, if I give you the line, and for this line, let's call it A and B. And for this line, I can say that there are 2 points with respect to the lines, and they are x1, y1 and x2, y2. So with respect to this x2, y2, the gradient is actually the ratio for y2 minus y1 divided by x2 minus x1. So I can also relate it to trigonometry, and I can say that the gradient is actually the ratio of y2 minus y1 divided by x2 minus x1, which we can say by looking at the triangle that we have just obtained, and which is also a right angle triangle. So we can say that if I say it's a y2 minus y1, then basically it's the perpendicular side or the opposite side of the triangle divided by the base, or we can call it the adjacent side of the triangle here. So gradient can also be represented as perpendicular over the base, which from trigonometry we know is the ratio for tan theta. Therefore, the gradient can be represented with respect to the x-axis as the ratio of the vertical to the horizontal, and also we can say that it is the rise with respect to the horizontal. So we can say that a line from the horizontal can be raised by a particular angle, which can be represented as tan theta equals y2 minus y1 divided by x2 minus x1, which is perpendicular over base. Or we can give the gradient with respect to the ratio of the change in the y values divided by the change with respect to the x values. Types of gradients. For a straight line, there are 4 shapes that a straight line can obtain. The line, the straight line, it can be sloping upward, it can be sloping downward, it can be a straight horizontal, and it can be a straight vertical. So these are the 4 types of straight lines that we can have here. Now with respect to the 4 types, the gradient value is such that we can say that for the line which slopes upward, the gradient will always be a positive. For the straight line which slopes downward, we can say that the gradient needs to be a negative. And the straight line which is horizontal, we can say that the gradient is equals to a 0. And for the straight vertical, the gradient will always be infinity. So these are the 4 types of gradients that we can be having, that we should be having for a straight line. So for the line which slopes upward, the change in y is a positive, y increases. For the line which slopes downwards, y value is decreasing, therefore the gradient is a negative. For a straight horizontal line, the gradient will always be a 0 as there is no change in the y value. So if there is no change in the y value, we know that y2 minus y1 will be equal to 0, and the gradient comes out to be a 0. And for the straight vertical line, the gradient is infinity because x2 minus x1, there is no change in the x values, that is a 0, and we can say that it's the gradient y2 minus y1, x2 minus x1, 0 for all vertical lines. And we know that for all values divided by 0, the answer is undefined or infinity. So for all vertical lines, the gradient is undefined. For all horizontal lines, the gradient is a 0. For all the lines with slopes downwards, the gradient is a negative. And for all the lines sloping upwards, y values increasing, the gradient is a positive. So these are the four types of gradients that we may be having for a straight line. So let's solve some examples to get the concept more easily. So let's say we have a straight line with 2 points A 2, 3 and point B having coordinates 4, 8, and we have to find the gradient of this line. So we can very well say that the gradient is equals to y2 minus y1 divided by x2 minus x1, and in this case I should say it's at 8 minus 3 divided by 4 minus 2. While solving it, make sure that your coordinates are in correspondence, meaning I should be very particular that 8 and 4, they should be representing the coordinates of point B, and 3 and 2, they should be representing the coordinates of point A here. So 8 minus 3, that will give me a 5, and 4 minus 2 is a 2. Therefore, I know that the gradient for this line comes out to be a 5 by 2 here. Let's do another example. So I am given 3, 5 as the point x and the y point having coordinates as 7 and a negative 2. If I have sketched the 2 points on the x and the y axes, and I can see that the shape of the line is actually going down, it's sloping downwards. Therefore, just by looking at the line, I can see that the gradient has to be a negative value. And also I know that the x is increasing from 3 to 7. X is increasing from 3 to 7. From here, I know that x is increasing from 3 till 7, and the y value is decreasing from 5 to negative 2. So x increasing, y decreasing. I know it from the given points that the gradient has to be a negative gradient here. So let's substitute the values and see if it comes out to be a negative. I can say it's a negative 2, negative 5 divided by 7 minus 3, which gives me a negative 7 divided by 4. So this actually is the gradient of the line xy that we have here. So now for the example that we have, we know that point P has coordinates 5, 4, Q has coordinates 5, 9. I have sketched the points on the x and the y axes, and what I can see here is that the line is a straight vertical line. So just by looking at the line and then looking at the fact that my x coordinate was a 5, I know that the gradient is only moving in the y direction. Therefore, I can just tell that the gradient is infinity. But let's do it by the formula also. I know that the gradient value has to be yq minus y coordinate of p divided by xq minus the x coordinate of p. Meaning I can say it's a 9 minus 4 divided by 5 minus 5, or I can say it's a 5 divided by 0. Any number divided by 0 is infinity or it's undefined. Therefore, the gradient for this equation comes out to be undefined here. So this is the third example or the third type of gradient that we have over here. So find the gradient of the 2 points s minus 2 and 3, t 5, 3. Again, I have sketched s and t on the x and the y axes, and what I have come to see here is that my y coordinate being constant, the change in y needs to be a 0. Therefore, the gradient needs to be a 0 over here. Let's do it by the formula also. The gradient formula says it has to be yt minus ys divided by xt minus the x coordinate of s. Substituting the values, I can say it's a 3 minus 3 divided by 5 minus 2. 3 minus 3 equals a 0 divided by 5 plus 2, that gives me a 7, but again the gradient comes out to be a 0 here. So this is how we should be having the 4 types of gradients for a straight line. Now do this question. Find the gradient of the given line. So I have been given a line on the graph representing the x-axis and the y-axis. So to find the gradient, we know that the gradient formula is y2 minus y1 over x2 minus x1. And as discussed earlier, we know that we can also say it's the ratio of rise to run, or we can say it's the ratio for vertical change over horizontal change. So if we are given this graph, we can get the gradient very easily. We have discussed the cases where we said that there are four types of gradients. When the line slopes up, meaning if the y values are increasing, then the gradient is a positive. If the line slopes down, the gradient is a negative. For horizontal line, the gradient is 0. And for vertical lines, it is undefined. So in this case, if I look at the line, what I know is that the y values are increasing. The y values, they are increasing, and the x values are also increasing here. So if y and x both are increasing, the line slopes up, and we are very sure that the gradient in this case should be having a positive sign. Now, instead of applying the formula, if this diagram is given to us, from this diagram, I know that there are 2 points which are very much obvious. One is 0, 3, and the other is 2, 6. So with respect to these 2 points, I can make a right-angled triangle. And with this right-angled triangle, I can have the vertical change as well as the horizontal change here. So the vertical change in this case is going to be 6 minus 3, which is equals to 3, and the horizontal change is going to be 2 minus 0, which is equals to 2. So I can very easily give the gradient, and I can say that the gradient for this line is equals to 3 divided by 2. So this is how easy it becomes when we are given a line. Just by looking at the shape of the line, whether it is sloping up or sloping down or horizontal or vertical, we can decide the sign of the gradient, and after that we can get the vertical change, horizontal change, and we have the ratio for the gradient value. Let's do another question. Find the gradient of the given line. Now to find the gradient of the given line, first analyze the sign of the gradient. I can see that it's the line which is sloping down, meaning what I see here is that y values are basically decreasing. They are on the decreasing side, and the x values are on the increasing side. The line slopes down. I know that this line, it's sloping down. Therefore, the gradient should be having a negative sign here. Now, next thing is to find the gradient value or the gradient ratio. Let's define some of the points which are very clearly known to us. Here it's a negative 1, 0, and here I can see that this point is very much clear with the gradient as negative 2 and 3. With respect to the two given points, I can make a right angle triangle from where I will be having the vertical change and the horizontal change. My vertical change is 3 minus 0, which is equals to 3. And the base or the change in horizontal line is a 1 unit. This line being sloping down, I can very easily say that the gradient has a negative sign. The vertical change is a 3 and the horizontal change is a 1. Therefore, this line should have the gradient which is equal to a negative 3 here. So this is how easy it is to get the gradient value. Once you get to know the shape of the line, sloping up, sloping down, and we can see that we just need to have the vertical change compared to the horizontal change, and we can have the gradient value here. So let's do another question. The gradient of the line joining the points 9, a and 2a, 1 is 2 by a, where a is not equal to 0. So find the possible values of a. So to underline the keywords here, we are given the gradient, and the gradient here is a 2 by a. And there are 2 points given to us. One is 9a and the other is a 2a, comma, -1. And then we are supposed to get the possible values of a. Make sure, so when you are reading the question, make sure that they are asking for possible values of a, meaning a should be having more than one value here. So let's start the solution. Let's collect the data first. I can have the 2 points as a, which is 9, a. I can have the second point, which is 2a, 1, and also they have given us the gradient, which is 2 divided by a. So applying the gradient formula, it's m, which is equals to y2 minus y1 over x2 minus x1. I can say that it is 1 minus a divided by 2a minus 9. So the gradient in terms of a after substituting the values is 1 minus a over 2a minus 9. The gradient is already given to us. It's a 2 by 9, 2 by a. So inserting the value, it's 2 by a, which is equals to 1 minus a divided by 2a minus 9. Solving it further, just cross multiply. I can say it is 2 times 2a minus 9, which is equal to a times 1 minus a. So this is a 4a minus 18, which is equals to a minus a square. I'm getting a quadratic equation here. Rearranging them, I can say this is a square plus 4a minus a minus 18, which is equals to 0, or it is a square plus 3a minus 18, which is equal to 0. Quadratic equation, if I factorize it, I know that the factors of 18 should be 6a minus 3a minus 18, which is equals to 0. So this is a common, you are left with a plus 6, minus 3 common, you are left again with a plus 6, which is equals to 0. So I can say that it's a plus 6 and a minus 3, which is equal to 0. And the values of a are negative 6 and a positive 3. So this is how I can get the two values of a. The points P 2, minus 3, Q 3, minus 2, and R 8, Z are collinear. That means they are lying on a straight line. So find the value of Z. So Z is the y coordinate of R, which is unknown, and this is what we are supposed to find out. So if the 3 points, they are collinear, that means they lie on a straight line. So if they are on a straight line, then just remember for all collinear points, the gradient obviously has to be the same. That means I can say that it's the gradient of PQ, which can be equal to the gradient of QR, which can also be equal to the gradient of PR. All the 3 points, they are on the same line. The line will be having, the straight line will have a constant gradient. Therefore, all the 3 ratios will be equal by the 3 different points here. So to get the gradient of PQ, I know that my P coordinates are 2 and negative 3, and my Q coordinates are 3 and negative 2. So substituting the values, I can say it's the y coordinate of Q, y coordinate of P, change in y, over x coordinate of Q minus the x coordinate of P. Therefore, I can say this is negative 2, negative, negative 3 divided by 3 minus 2 here. Or I can say that the gradient of PQ will be equal to negative 2 plus 3 divided by 1. or this gradient comes out to be a positive 1. The line was sloping up, it had to be a positive. So MPQ can be equal to find Z, which is the y coordinate of R. MQR, I know that MPQ is equal to a 1. I have already found it out. So QR, I know that coordinates of Q are 3, -2, and coordinates of R are 8, and y coordinate is a Z. Therefore, I can say that it is Z -2 divided by 8 minus 3, or further solving it, it's 1, which is equals to Z plus 2 divided by 5, or 5, which is equals to Z plus 2, or 5 minus 2 will be equal to Z. So very easily I can say that the Z value has to be a positive 3 here. So this is how we will be finding out the Z coordinate. So this is all about gradients. I hope the concept is clear, and you can solve the gradient equations very clearly now. So the next topic will be equation of a straight line.